Hi, I'm Ian with Mastercam, and welcome to Tips and Tricks. Programming a CNC router, especially a large 5-axis router, can present some unique challenges, but this also means that there are some unique solutions you may not have thought of. So in this video, we're going to show you how to use the saw on your 5-axis router as a multi-axis roughing tool. The part we'll be working with for this demonstration is based on a stair tread from a custom spiral staircase. In this example, the top of the tread has already been completed, and a fixture has been created to hold the tread while the bottom's machined. Using section view, we can see how the fixture locates and holds the part to be cut. The stock for the rear of the tread is glued on after the top of the tread has already been machined. Utilizing the material rendering settings in Mastercam, we can see how the part geometry fits within the stock. An efficient multi-axis toolpath starts with having good drive geometry. Since we'll be using a multi-axis toolpath for this operation, we've created a simple line and surface for the toolpath to follow to ensure that the toolpath motion is clean. We'll now launch a long curve, and on the Tool tab, select the saw. On the Cut Parameters page, select the line as the chain for the lead and the surfaces as the drive surfaces. Set the drive surface offset to 1 mm. In sorting, we'll set the cutting method to one way. In surface quality, we'll set the cut tolerance to 0.05 mm, and we'll set the maximum step over to 3 mm. The teeth on the saw we're using have a total radius of 10 mm, so a 3 mm step over is going to minimize the cusps that need to be cleaned up later. On the tool axis control page, we need to set the side tilt definition to follow surface ISO direction. We'll also need to change the tilt angle at side of cutting direction as well. When the angle is set to 0 degrees, the axis of the spindle is normal to the surface. Since we're cutting with a saw, we need to set the angle to 90 degrees, so that way the saw itself is perpendicular to the surface. We're not going to set any collision control options at this time either. Before worrying about collision control settings, it's more important to make sure that the toolpath motion is smooth and uniform. This is going to help make collision control easier to set up later when we do need it. So on the linking page under Gaps Along Cut, we'll set the small gaps to retract the clearance area. And under Clearance Area, we're going to set the type to cylinder with a radius of 500 mm. We can now green check to close the toolpath dialog. And let's take a look at the toolpath so far. Now that the toolpath has good, clean motion, it's time to apply that motion to the part itself. To do this, we're not going to change any of the drive geometry being used. Instead, we're going to use the check surfaces on the collision control page to offset the toolpath to the part itself. Now we're going to make sure that we have selected flute, shoulder, and shank, and that we set our strategy to retract tool along surface normal. Next, we'll set our check surfaces. We'll set our stock to leave at 0.5 mm and green check to close the toolpath dialog. Now let's generate the toolpath and see how it looks. By creating simple drive geometry to control the motion of the tool, while using the check geometry to offset the toolpath to the part itself, we have a clean and uniform toolpath. Now, this is going to result in less NC and a smoother, faster toolpath to cut at the machine. But we're not done yet. There's one more thing we need to take into consideration, and that's the tilt of the saw. If the saw remains parallel to the table of the machine during the entire cut, then when it gets to the bottom, the arbor of the saw might collide with the part before it's able to fully cut the selected geometry. But we can address this issue with one simple setting. Let's expand the tree for tool axis control and select the Advanced Options page. Set the gradual side tilt angle change to 10 degrees. Gradual tilt will slowly tilt the tool as it moves towards the end of the tool path. By doing this, the saw will have enough tilt to cut the entire surface while keeping the arbor clear of the part. We can regenerate the tool path one last time, and we'll launch machine simulation to see how the tool path looks. That's all for this episode of Tips and Tricks. We hope you found this informative, and make sure to visit Mastercam.com for more information. Or if you're interested in formal Mastercam training and certification, visit university.mastercam.com.